Are there any questions before we get started?
Is there any point through this course that we might have time to go over ICAs? I understand we're on a pretty tight time crunch, but
Yeah, no, we will have time for checklists.
at some point.
Yeah, and I expect today to have some time at the end.
Okay. Just general question.
Problem is that we started 1 week short.
Yeah.
So we're gonna have 1 hour. Okay. Any other questions? Okay. Let's do a bit of a. Yeah.
I just want to confirm if you will still go through the library stuff or you're done with it.
Yeah. Well, we are kind of done with it, but we're going to recap. So we're going to do that. So what is the first step for using a library? Included. Well, I guess we are not counting the step of actually creating the library, right? Before using it. And I guess we give you the .h, you code the .c, you include the .h, blah, blah, blah. Is that all that clear? That part? Okay. So include the library. Whatever this one is called, right? And I guess that's about it. So what's the second step?
I don't think that's
Write the fraction for the H. Write
Location?
Write the fraction. One.
For you mean the location where it is?
No.
Oh, write the functions.
Yeah.
Yeah, well, that should have been implemented in the .c, right? So we assume that at this point the library is already complete, right? So we coded from the C, from the H, we coded all the C's. Is that part clear or not? I just did the lesson earlier with the other class. See, I renamed this, the one that we had, to underscore GPIO because I coded this one. And the way this started, it was, I downloaded this one from Brightspace and I literally copy pasted this thing without the semicolon, and I added curly brackets and I did the implementation of each one of them. Now notice that these prototypes contain only the type, whereas in here I need to add a library, a variable name, okay? Why does this one only contain the type? Because this is just a function prototype. And where does everything start? Well, it starts from here. See how we have this function implementation here, and we have this prototype here. So what we're doing with the libraries, we're saying, you know what? I'm going to put you on a library. You go to my library.c, and you will be the signature. You go to my library.h. That's what I'm doing, okay? That is why I'm giving you all the prototypes. The prototypes only state the signature of the function. What does it return? Function name. Does it take any parameters? That is what I'm giving you here. For example, init input. It returns nothing because it's void. It takes a pointer to GPIO, and it takes a number, a 16-bit number. Well, that might be a bit too big for what because the number that we're putting in here goes from 0 to 15, right? So, and I'm even telling you which one is each parameter. Is the port, this one is the pin. So I'm giving you this description. Now, I don't have a variable name. I'm doing this intentionally, although I know that you guys may get confused, but the reason why I'm doing this is because I want to stress the fact that this is just the prototype. It's not the implementation. When it comes to the implementation, is where you add the variable names and you actually implement the function. Actually, that one is not implemented intentionally, right? So I can leave some fun for you, but how can I give you everything that is no fun, right? Questions up to this one? This is what you're gonna do. You're gonna grab one of these and you're gonna do the implementation. Now, if you don't know how to do this, you know how I coded this one? See, this may help. Let's say I don't have this one. Let's say I don't have anything. I don't have anything. I don't have any libraries. How do I even start? Well, I go to the demo prior to the library, this one. And in this demo, how did I set up PA5 as an output? Like this, right? So if you copy this and put it here in the init output. Obviously, I'm not using this one. Now, is this going to work off the shelf?
No.
No, because I'm not talking about GPIO-A. I'm talking about any port. So what do I replace this with? P ports. Simple as that. Now, these settings were for setting PA5 as an output. Now I want to set any pin as an output. What do I change?
5.
The 5 with the pin. As simple as that. Done. To toggle. This is toggle, right?
Yeah.
In case we have forgotten, this is toggle. GPIO toggle. Well, I don't want to toggle PA5. I want to toggle any port in any pin. Well, is this correct or not?
Should be. Still a good question. It's not correct.
No.
ODR is this.
Yeah, it's correct.
If I toggle with, let's say if I pass pin 5, I'm going to toggle with 5, and 5 has a 1 here and a 1 here, right? That is 5. So I'm going to be toggling 2 pins. That's not what I want. I just want to toggle pin 5. So in whatever I'm passing, I want to have a 1 here, right? If it's 5. If it's 4, I want to have a 1 here. So basically, I'm looking for a 1 be shifted to the left by the number of the pin.
1 left pin.
It's the same as this. It's just that it's a bit different because this one is times 2 because it uses 2 bits. The motor uses 2 bits, whereas the ODR uses just the 1. Okay. See, this is showing you how easy it is to code this library. Now, how do I do a set? I gotta change one thing.
XOR with an AND.
Set. Not clear.
Oh, sorry, or.
Done. See how easy this is? And this will be set. How do I do clear? Well, clear is a bit trickier. So, in that one I need to use an and I need to reverse the,
No.
see, at the end of the day, this is just creating a mask, right? It's creating a mask because it's starting with a 1 and be shifting to the left by pin. So now I need to reverse or invert this mask, right? And in this case, I need to use brackets. Done. This will be clear. And that's how I construct my library. Now, if you see this rec quickly here, it's just a VS Code that is, because VS Code thinks that we're using this GPIO, the one that is in Microsoft. We're not using that one. We're using our GPIO. So not to worry about this one. The library will, Sega Embedded Studio will handle it. How do I read a pin? Remember that to read a pin, I'm trying to read something that is changed by the hardware. So how do I read a pin? According to the lesson I have, remember, you should be looking at this lesson. Interacting with port and pin. Write into a pin, configure in pin modes, write into a pin, set, toggle clear. It's all here. Now, this is using the masks, to be fair. But these masks, if you use them and you hover on them, it's just going to have a 1 bit shifted to the left by a number. In this case, 3. In this case, 6. It's the same thing. Now, how do I check for a bit? Well, I just mask the input data register with the actual mask. Because the mask has only a 1 on the bit of interest, in this case is a bit 4. So the only possibility that this is true is when the port in the IDR register actually has a 1 on the bit 4. That's the only possibility of this being true. And that means that the pin is high, otherwise it's low. Is that part clear or not? Not so much, it looks like.
No.
Input data register, this guy. What does the R mean?
Read.
It's read only. So you can only read this register. What does that mean? The software can only read it. It means that the software cannot change it. So who does change it then? One. Who changes it? Huh? The hardware. When you press a button, you will change it. Okay, so how can the software know about that? The software needs to mask the bit to see if it's a 1 or a 0. How do you mask it? You grab this register and you AND it with a mask that has only a 1 on the bit of interest and everything else is 0. In this particular demo that I had before, well, I don't have a mask in here, but let's say I do want to have a mask. Let's say I add it. How do I want to do this? Let's say I'm going to check the GPIO IDR, and I want to check if PA3 is high. How can I check that? Well, I'm going to look at the IDR register, and I'm going to AND it with a mask. Which mask? GPIO underscore IDR underscore ID what? ID3. That means it's high. Pin is high. Otherwise, pin is low. Is that clear?
Yes.
Great. Now, how do you code this in your library? Well, if you hover on this guy, this one is a 1 be shifted to the left by 3. It's telling you that.
So 1 bit shifted by pin.
It's as simple as that. That's what I'm doing here. Okay? If that is the case, I return 1, meaning that the pin is high. Otherwise, I return 0. I don't have an else here because if this doesn't happen, it's just going to go straight to this one and return 0. And if this happens, it will return 1 and it will never reach this one. So that is the way this is normally done in C to avoid having an else. Now, if you don't like it, you can just add an else and it will work still. Put this inside the else. If it makes you happier, by all means.
It's just more explicit.
Yeah. That is the thing, is C is not user-friendly. That is the problem. Yeah, it's ugly. I agree. Yeah. It's not a pretty language. C# is much prettier. Let's see. Now, which one will make more money eventually? That is to discuss. Currently, I would say C, but who knows in 20 years?
It's because everyone does everything on C.
Yeah. So is this clear in how to create our libraries? Because basically I'm giving you the entire library almost, which I didn't do last term, right? So don't expect me to do the same thing. So here's the thing, the same thing happened with 1550. I gave a little bit of extra help because I wanted the students to move through the ones that, you know, met the minimum requirements to arrive to this course, right? But once you arrive to this course, it's a different story. And I keep saying that this is not 1550. It's not that you can accumulate all the assignments till the end and get all the checkoffs at the end. No, it doesn't work like that. I will still be willing to give you checkoff, but you will be too far behind if you do that. And you will be totally lost at that point. So you need to stay on track. Okay? Alright, so assuming that we know now how to code our library, we include it to use it. What is the second step? Going back to the lesson that we had, remember last class, we did the whole process, and I intentionally did this step, and then something failed. And how did I fix it? What was the second step?
Location.
The location, actually, that was the third step. It was the second one that I did. Or maybe no. Yeah, you're right. So add library location, and that happens where? You go to the project, right click, options, preprocessor, user include directories. So project, options, preprocessor, and then user include directories.
You physically locate it on the drive. And
Yeah, now please know that this location is relative to the project itself. That's why we keep a folder structure. I go one level up, two levels up, and then I look for lib, and then I look for ink. Okay. That's the second step. When we did that one, it still didn't work. We had to do one more thing.
Enable clocks.
Huh?
Enable clocks.
Enable
Clocks.
clocks.
Yeah.
No, that's to enable actually the GPIO. That has nothing to do with the library, but that's a good point. There's one more step to make the library work.
Drag that near the main.
Drag and drop. Drop, not prop. Drag and drop. Leave that in. Sorry, that's C. I'm just calling a generic name, right? So just gonna say this. So we need to add the implementation file so the compiler can know where is the implementation. And that one we just drag and drop it here in the source files. That's what I've done. Okay? Once we have all that, we can just beautifully run these demos. And if we rebuild, it builds properly and it runs properly. Now, Carl was absolutely right. We need to enable the port in the clock first before we can use it. But now we enable this one as an output. How do we know our library is working? We can debug. We can run this and the code stopped there. Remember, to see the GPIO-A, we need to go here and enable it because it's disabled by default. And we look at the motor 5. The motor 5 should change from 3 to 1 after this line. I press F10 and it changed from 3 to 1. Why? Because if you look at the motor, 1 is general purpose output. But in order to do that, we had to do two steps in our library. We had to clear the 2 bits and then write a 0-1. Remember? There were 2 steps. Now it shows just like 1 because the library is doing it for us. Then for the toggle, if I reach to that point, I look at the ODR, and now PA5, every time I go through here to toggle. So now it's going to toggle from 0 to 1. Pay attention, 1, 0, 1, 0, 1. So the ODR is actually toggling. Moreover, we can see it toggling. And it's exactly, more or less, 1 millisecond. So I had to tweak my delay 1 millisecond library to 1777 because now the call to the function adds a little bit of overhead, so I had to drop this number a little bit. Right? Now I had a very interesting question in the other section, very smart question. Should we put this in a library? I say, sure, why not? Later on, we're going to dump this because we're going to use timers. But for now, yes, you can have it as a utility you can have your delay 1 millisecond and your delay underscore milliseconds, or whatever you want to call it, that will delay X milliseconds. And you can create your own libraries, call it utilities, call it utils. It will be an excellent way to practice how to create and use libraries. Okay? And anything that you want to add there, you can add. Any questions?
Wouldn't just including this delay, because it sounds like if you're having to adjust every time we're doing different functions, that's going to need to be manually adjusted to make sure that this delay is in fact 1 millisecond, right?
Well, now it's already adjusted. Every time you call this function, it's going to be more or less 1 millisecond.
Oh, okay.
Yeah. I wouldn't worry too much about that though, because later on we're going to use timers to generate accurate time events. But for now, we're just using an intuitive approach. We want to modularize our code as much as possible. So then, because if we're writing everything from scratch, always is too much, right? But if we can modularize things like this, then we can just use the GPIOs with no issues, save for the timing. Okay?
When do you want our libraries to be made?
As soon as possible, because I'm going to release assignment 3, and what I'm actually going to do, I'm going to condense assignment 3 and 4 from last term and make it just one, because that was too much. I want to make the assignments this term more straight to the point. Because last term we spent too much time, the assignments were way too long, and we need to focus on what's the most important thing. One of the things that we're going to evaluate in this coming assignment that will be released probably tomorrow is that doing this versus doing it directly on the registers. Obviously, you know already that there's a bit of an overhead when you call a function, right? So we're going to experiment what happens when I do this versus GPIO A pointing to ODR exclusive or equals and whatever, so we can see the difference, right? We're also going to look at the delay cycles, and then I can already give you a little bit of a spoiler of what's coming. What if I wanted to toggle two different pins, one at 1 milliseconds and another one at 10 milliseconds? So let's say I want to use, you know what? Let's do it. Let's create another project. Library demo 1. How are we doing with time? Oh, we got plenty of time. It's 2 hours for us today, right?
Yes, sir.
Library demo 2. Now that I have a library sort of like working, I can do things faster, right? I'm going to delete this 2 and open this guy. Hopefully I don't have the other one open, because when I have 2 open, then it generates an issue. Rename this guy. And the pin that is just below PA5 on the board, what would that be, PA6? Let's take a look.
It's going from 0 to
PA5 is here, yeah, PA6 is right below. Let's say I want to toggle 2 pins instead of 1. So what I'm going to do, ooh, not that one. What I'm going to do is, I'm going to say, well, configure now also PA6 as an output, okay? So now this is going to change just like that. See how beautiful it is to have a library. Now it's so easy. And I'm going to say toggle PA6 at 1 milliseconds and PA5 PA6 at 1 millisecond. I'm going to do that. And PA5 at 10 milliseconds. and actually did something similar to this in last term's exam. And was a bit of a catastrophe. Because, well, I need another function here. Let's add it here because I don't have my utils. I'm gonna call this one delay milliseconds, like that, okay? And this one is gonna take a UINT16. I'm just gonna make a new UX16 because I don't expect to pass in like a huge number, no more than 65,535. So this one's gonna be called delay. Well, you know what? I don't even have to have a name there. Since I like to make it complicated, why not? So let's go here. And now here we add the name. And this is what I was telling you, some of you that were struggling with this. Then all you needed to do was this. For int I equals 0, right? What else? I less than delay. Then I plus plus. Then what? Delay 1 millisecond. As simple as that. Now, if I want to toggle just PA5 for now, at 10 milliseconds, let's see if that works. Looking out our scope. Yeah, it's working perfectly. Look at that. Right? Now, here's where the catastrophe starts. I want to toggle also PA6 at 1 millisecond. And the students did this. And you're going to tell me, well, you could do this or call it with 1 millisecond. It doesn't matter. And, well, that doesn't work. We know it doesn't work, but we're going to put the other proof right next to it to show you what's happening. In the meantime, I'll let you think about it. I'll let you think what is wrong in that, and you tell me later. I'm going to connect the next one to the second probe, bring up channel 2, run this demo, and everything both should actually toggle. I need to have the positive width for the signal 2. Okay, so this is the result I have with that. They're actually both toggling at more or less 11 milliseconds. So what I want obviously is not working.
They're out of phase.
Why?
Don't you want to and them together somehow?
Here's the thing. You know, every time I go to the gym, I see some people that have huge bottles of water. My bottle is quite decent size still, but not as huge as. What happens if you have 3 people trying to fill up their water, and this guy comes into the fountain with a huge thing?
It adds delay.
Everyone else behind him is, I don't want to use a bad word for it, but they basically gotta wait for that guy to finish. So it doesn't work. But here's the thing. What if I say this? You know what? Each one of you is just gonna fill up, if it were possible, because obviously you cannot measure that. But each one of you is just gonna fill up to 100 milliliters water. And then you're gonna get out and let the next one go, and go, and go. And everyone will keep going. So eventually, the one that has the smallest bottle will exit first. Then the next one, and then the next one. And probably the guy who has the largest bottle will take the longest time, and it will exit last. But that will be fair, right? Because why would you make someone who is just waiting to fill up this bottle so much, because the other guy has a huge, like, I don't know how many liters, right? This is exactly what's happening here. So this guy wants to toggle at 1 millisecond, and this one wants to toggle at 10, but this is blocking delay. So this guy is the bottleneck.
It almost adds them together and it creates an 11 millisecond.
Yeah. So how do we solve that problem?
Separate while loop.
Okay, let's make some groups, or works alone, whatever, on groups. And I want you to solve this problem. I'm gonna push this demo, and I want you guys to come up with a solution. And once you're done, you let me know.
I feel like some people in this class are gonna be. I got it.
But everybody understands what the problem is, right?
Yeah. It's, so it almost sounds like you only want the loop to run once for the 1 millisecond, and you want the loop to run 10 times for the 10 millisecond.
I have modified that.
Well, yeah, because you have one at 1 millisecond, one at 10 milliseconds, and then when Carlos popped it up here, it was called
Okay, demo is pushed.
milliseconds.
And by the way, you know what? This is the biggest problem in this course. Once you're able to change the mindset and think differently about this, you will understand what's going on in this course. Everything is happening in this loop. You don't have multi-threading like in the other programming courses.
Hold on, I gotta pull the demo.
Yeah, you guys can collaborate with each other. Don't work alone. This doesn't happen.
Sorry, say that again, sir. Yeah. I'll be back. I'm gonna go to the office.
Oh, it's like the oh, yeah. First, that was 2 days later, right? Yeah.
Okay, are you saying that like the delay for that pin is still technically saved
Deal with that.
in the other one? So you'd have to clear it first
Yeah.
and then do it again?
Yeah.
I mean, it's an easy
Which
theory.
one? This one?
I'm not saying it's wrong, it's like, it's a good
This
theory.
one?
I wonder if it, hold
No,
on.
it's-
I'm gonna see,
Nope. It's for 250.
pull the main repo, and it looks like there's a pull request for this one here. So if we pull that one, I really hope this doesn't break. Oh, thank God.
You start with GitHub.
So, and that was 12. Yeah, you wanna go back into your GitHub desktop and do a pull request.
This one?
Yeah, so,
Your class demos?
what I would do first
No,
is I would go to your home
that one
folder
don't have a go.
and do just like a pull. You can go up to here and on repo
This one?
and just select pull. And that's just in case. And then allow it to finish the pull request.
Like I have down this
So
one.
it's gonna push, so I wouldn't worry too much about that. And then if you go back up there again, and then go back into your submodule, the in-class demo one, you can even see there it's got a pull request. So wait for it to fetch first. And then you can click on that, I'm paranoid. I go up to repo just here. And I just go pull.
No. Yes. Should be 10. 11. Maybe try to clone it again. The other link.
Stash changes and continue.
No,
So it looks like you try to do a push request. So what happened is you altered the code inside of the in-class demo folder. You do not have write
That's
access
for
to that.
250.
So what I've been doing,
Oh, yeah.
I've been going into the in-class demos,
That's
I'm
my
just copying the demo.
Yeah.
So like where it is in the folder, I'm just copying the demo.
It's
And
fine.
I have another folder, because we have write access to the main folder, just not that in-class demo. So then I put it here instead,
Too much.
and now you can mess around with it all you want, and then it's not gonna cause these issues. So you can just keep that stashed, because you're never gonna be able to do a push or a push for that
This one?
change anyway. So you just
Yeah,
keep it
yeah, yeah.
stashed forever. I'm not sure actually how you maybe a couple.
Okay. Try open it with, try to open.
Yeah, that's at least what I've been doing. I make a copy of it, and then from there you can alter it. It doesn't really mess with your.
For cloning it. Yeah, find this one. Okay.
Oh, yeah, right there. So then just copy that one. Oh, not kidding more. Yeah.
Nice. Too many.
Okay, we'll just get a free
Find that one.
cat house.
Just an observation, I don't see any oscilloscope, oh, I see one oscilloscope turn on. We should be testing this on the scope.
I feel like he just told us to get the hell out of the seats and go test it on the scope.
Well,
Oh, yeah, that one.
if you have an idea, how are you gonna know if it works or not?
What if I don't have an idea
What if we're doing some planning? No, he's right.
See it when